So here we have day 11 for today. You can see I already have some things written down here. This is page 53 of our module book, and we're going to talk about unit rate as the scale factor. And no, that is not the bell for you to leave class yet. So first thing is first, yesterday in Fast and Furious we talked about how to find a scale factor. You take the scale and you divide it by the actual. All right, so really day 11 is split into two skills, and there's actually two different videos. So this first video is finding the scale factor. The second video is going to be the lesson objective. I can find actual measures using a scale factor. So why don't you just hit pause so that you can fill that information in. All right, so now that we're back, we're going to look at this first example. And we got Celeste drew an outline of a building for a diagram, and then drew a scale one mimicking her original. So on the left, we have the original, which sometimes we refer to as the actual. And then over here, we have the scale. Right. And what we're going to do is, it says state the coordinates. We're not going to worry about stating the coordinates. We're just going to fill in the table below. So we're going to look at, down here in this table, the actual versus the scale drawing. So we're going to look at the actual. We're going to find the height and the length. So to find the height, okay, each one of these is 5, so I can go 5, 10, 15, 16, 17, 18. So the actual height is 18. The width, 1, 2, 3, 4, 5, 6. So I have 18 by 6. Okay. On my scale, I now have 5, 6, 7, 8, 9. The height is 9. And the width is 3. All right. So now we're going to, how this relates to what we've been doing so far, is think of your actual as being your x, think of the scale as being a y when we have a horizontal table. All right? And if we were to find the constant of proportionality, y over x, match them up here and here. So we would have 3 over 6. You always take the y over the x. Okay, some of us are still making that mistake of taking the larger number over the smaller, and it's not always the case. Okay? This comes out to be 0.5, or scale factors, we really like to look at them. Well, when I make that connection to the scale factor, we really like to use the fraction version of it. All right? And then we do 9 over 18, which is also 0.5, which is the same as a half. So what we can state about the relationship between the actual and the scale is that it represents a proportional relationship. If I could write. Because these unit rates, your constants, are the same. Okay? So here's the relationship between the constant of proportionality and how that relates to scale drawings. The constant of proportionality is the scale factor. Okay? And your y over x, your scale measurement, is going to be your y, and your actual measurement. So if you think about depends, the measurement on the scale drawing depends on what the actual drawing is going to be. So in these relationships about being drawn to scale, okay, we also would say they have the same shape, but a different size. All right, so turning the page over here, 4 minutes in. The key idea, okay, at some point you can read, but the grand idea is that the scale factor is the scale drawing to the word corresponding in the actual. Okay, the scale factor corresponds to the unit rate and the constant of proportionality. All right, so let's look at example number 2. What is the scale factor? So immediately, scale over actual. Right. So let's read. Giovanni went to Los Angeles to visit his cousins. Oh, do you notice how I went right to the end? Okay, that's how we figure out the gist. He used a map of bus routes to determine to get from the airport to his cousin's house. The distance from the airport to his cousin's house is 56 kilometers. On his map, the distance is 4 centimeters. So obviously you have to figure out which one is actual and which one is scale. Well, the scale is going to be the map. So we got 4 centimeters over the actual, which is 56 kilometers. Now, when you divide this, I'm grabbing a calculator so you can see how nasty this looks when we actually divide it. So when I divide this and I do 4 divided by 56, I get this nasty decimal. Okay, scale factors should always be represented as fractions. So you can just hit second, fraction to decimal converter, and we get 1/14. So 1 centimeter is 14 kilometers. And this would be the scale factor. Okay, or sometimes they write it like this: 1 centimeter equals 14 kilometers. Okay. All right. So from here on, there's a checkpoint. Exercise 1, there's actually 2 problems here, so we'll call this one A, call this one B. There's your checkpoint. So you would check in with us, and before you move on to the second video, we need to make sure that you do these correctly. So this is Mr. Sims, signing off.